Hello. We're going to dive into our periodic table, group 1 alkaline metals. So this is 11 marks. This is actually a very standard paper 1 question. Quite high awarding, but not unattainable. So let's dive in. Okay, so with question 10, this is what we have. This question is a very standard way of starting an alkaline metal, which is basically a group 1 metal. Information here is we are dropping a piece of sodium, and if you can recall, or if you have a periodic table nearby, that would be lovely. Sodium is the second alkaline metal in this group, followed by potassium. Okay, so this teacher dropped a piece of sodium into cold water and she observed bubble of gas. Now take note, this observation is provided, so please do not repeat this observation. So here the question is asking you to state two others. In fact they emphasize on two others. So in this case, if you mention anything about fizzing or bubbling, you will not get any marks because it's already provided. Okay, so what else can you what other observation could you bring into this question so that you can get marks here? This first three alkaline metal, lithium, sodium and potassium, they are really lower in density. Low density, so I'm going to write this down. So their density is actually lower than water, lower density than H2O. I should put lower, not low. Okay, so they will actually float on water and they will also move as well. Now it's not enough to say they move like just what? Okay, you need to say that they move on the surface or they float on the surface. Again, you need to, that this will highlight the fact that they are low density metals, they don't sink. Okay, next, after a while they will melt into a ball, and in that process you actually see that they get smaller and smaller, and sometimes not all the time. I noticed this white through does not always happen all the time. So if you are going to observe this experiment again, like especially during your revision period, or like your teacher gets to repeat this experiment, do try to take note of the white trail. It does not always occur, in my opinion, in my personal experience as well. Okay, but 1, 2 and 3 definitely yes. Okay, so any two out of these 3 points will get you the 2 marks over there. So for this question, although it's very straightforward, the things to take note here is they have already given you this bubbling of gas in the question, so you do not repeat the effervescence or the bubbling or the fizzing in that case. Okay, so don't lose your marks like that. So read the question properly. Next, we are looking at writing a chemical equation. So they give you the reactant. Lithium react with fluorine. These are what we call reactant. Reactant is basically what you start off the reaction with, what are the chemicals that you put in there, and then you form. Okay, form. Every time you see the word form, you think of the arrow. Okay, because there's no equal sign in chemistry. They form lithium fluoride. Okay, so you can use your periodic table. Again, if periodic table should always be near you, so that will always be easy. If you look at lithium in the periodic table, it will just be Li. Okay, now the thing about fluorine here is just when a lot of students lose their marks. Okay, why so? I'm going to put a word hard here. Okay, because what we have here, we have a series of this what we call diatomic molecules. If you do follow my I Can Achieve Instagram, you see that I pinned this up as my first post. Okay, it's always there. The diatomic molecule are this ones. Okay, there's this pattern that you can see in the periodic table. If you have a periodic table nearby, you can see that this in the same period, which is period 2, and then you will have all your group 7 halogens. They also exist as diatomic molecule. Okay, so all of this exists as diatomic molecule. That means if you are required to write their formula, you need to present it in F2 or O2. Say for example, you've got hydrogen reacting with nitrogen to give us ammonia gas. Okay, essentially this is a reversible reaction. Yeah, okay, so these are things to take note of. Okay, so if you have forgotten this 2 over here, because fluorine is a diatomic molecule, chances are you're going to get a very different balanced chemical equation. Okay, so then how do we write this LIF if I'm going to change it to blue? Okay, lithium is in group 1, fluoride is in group 7. Okay, oh, this shouldn't be that case. Okay, it shouldn't be LIF2, it should be just LIF. Okay, so what's happening here is we have you can do a crisscross. So since they are both having 1 and 1, literally just pulling out the value of 1 here, isn't it? So one is a number that we do not need to write in chemistry, so you can just leave it as LIF. Okay, then you need to balance, because so if I were to go backwards and teach you how to do this balancing equation, you will see that there's 2 fluorine F2 on the left, so you need to put a 2 here to balance out the F on the right hand side, which is the product side. Okay, but this 2 will also affect the number of lithium, so you need to balance over here on the left hand side. So 2 before lithium and then 2 in front of lithium fluoride. So that's how we write out this chemical equation. So although this is an unconventional chemical equation, but they do provide you the reactant and they also provide you the product. So you should be able to use your periodic table and with knowledge of the ions, common ions in the periodic table, as well as the polyatomic ions. And what do I mean by the polyatomic ions? Yeah, I feel like I'm just adding on to the list of things that you need to memorize, and you're going to freak out a little bit, isn't it? Like this hydroxide, sulfate, carbonate, etc. Okay, so with all of this in mind, you would need to know all this as the basis, and you would be able to write out an equation that you hardly see. Okay, so take note of that. All right, next one is when we're going to ask for a test, a flame test, to show that lithium fluoride contains lithium ion. So understanding that lithium is our positive ion, so positive ion, and it can be identified using a flame test. So we would use this, conduct a flame test, and then you need to know the color. Okay, on the side note, positive ion can also be determined by using sodium hydroxide solution, but not for all, only for Cu2+, Fe2+, and F3 to 3+. Okay, so different positive ion, different cation have different tests. Flame test is just one of them. The other alternative is using sodium hydroxide. Okay, last one. For this question, we are supposed to draw, right? Draw the diagram to show the arrangement of electron in lithium ion and fluoride ion. Now, take note, they ask you to draw electrons, but because they didn't mention that you need to only draw the valence electron, so you need to draw everything, okay? Every electrons, okay? Because they did not emphasize that draw only the outermost electron or draw only the valence electron. So if nothing is mentioned, then you need to draw everything. So if you again look at the periodic table, lithium would have 3 electrons arranged in 2-1 configuration. Fluorine would have 9 electrons arranged in 2-7 configuration. So what's going to happen here is our lithium would actually be the metal, so it will lose this 1 valence electron to fluorine, okay, and then fluorine will end up with 2-8 configuration. Okay, so I'm going to draw out lithium first. Lithium, after it loses its, okay, it's supposed to be like this first, okay, 2-1, but it's going to lose this electron. Okay, so what we're going to do is we do not need to draw this last shell anymore. I'm going to take it away, but we need to put a bracket and we need to put a charge. Now, why is it positive? Quickly, okay. Now, each electron is negatively charged. So if it's negatively charged, every time you're losing a negative electron, it becomes more positive, right? So if you lose electron, it becomes a positive ion. Because you only lose 1, so it becomes positive 1. Okay, so if you lose 2, then it becomes 2+. Let me just rewrite this. Okay, just 1+. If you lose 3 valence electron, it becomes 3+. Okay, then what's going to happen to our fluoride? Okay, fluoride is going to gain. So I'm going to draw the original first. So 2 in the first shell, and then 1, 2, 3, 4, 5, 6, 7. So these are the original. And again, for easier for you to see, okay, the electron being gained, we need to, hopefully you will be able to draw it in the same symbol as the original, which is lithium, which is cross. Okay, so after it gained 1 electron, its charge will be minus. Okay, so this is how we draw out this. And if you look at the marks awarded is 3 marks. And how do you get 3 marks? Of course, you get 1 mark for lithium drawing and 1 mark for fluoride. And the third mark is whether you are able to give the correct charge for each ion. So on that same note, your group 7, okay, because it is going to gain 1 electron. So group 7 ion would be, like for example, chloride minus, fluoride minus. Okay, if it's group 6, you want to gain 2 electrons. So after gaining 2, it'll be O2 minus, S2 minus, etc. Okay, and if you were to just stop and think for a while, what do you think would be the charge of group 5 ions? So group 5, like for example nitrogen, okay, if it gains 3 electrons, it will have an overall charge of 3 minus. Okay, so that's how it is. All right, next one, we're going to look into question C. Question C is a longer mark question. We are looking at configuration of sodium and potassium. Now, just by looking at it, do you see any differences between the configuration of sodium and potassium? You will see that potassium has 4 shells, 4 electron shells, whereas sodium has 3 electron shells. Okay, and what this means is both of them have the same first shell, which is like 2 electrons. The second shell is also the same, 8 electron, but sodium only have 3 shells, and the third shell contains 1 valence electron. So the difference is the number of shells, and how we're going to use this number of shells to explain why potassium is more reactive than sodium. And you need to discuss in terms of electronic configuration, which is basically what is shown in the table. So the first way to, even if you don't know how to explain, use the table, use the clues to get the first mark. Okay, you could see just from the table alone that potassium has 1 more electron shell than sodium. And then what does this mean? This means that the outer electrons of potassium is further away from the nucleus, and so the main focus that you need to think about is here. So there's a weaker attraction between the electrons. In fact, the outer electron is the keyword, and the positive nucleus. I'm going to draw out a visual diagram for you to better understand this. So this results in the outer electron of potassium to be more easily lost than sodium. So how does this work? If I were to draw out potassium, okay, potassium 1, 2, 3, 4. Just going to use this. And then for sodium, it's Na, 1, 2, 3. So I'm just looking at the very last electron, the outer electrons here. Now, in the core of this is what we call the nucleus. In the nucleus, what we have in the nucleus are the positive proton and the neutron. So I'm not going to talk about the neutrons for now because they're neutral. But you see, the protons will be attracted to the valence electrons. But you see, because of the distance, okay, I'm just going to look at potassium, which is this one right now. The distance between the electrons, the outermost electrons, and the nucleus is further away than the one in sodium. So what's going to happen here is this distance resulted in a weaker attraction between the negative electrons and the positive nucleus. So because this attraction is weaker, it is easier for potassium to lose this valence electron. So you can think a bit of like long distance relationship, right? So it is harder to maintain a relationship when it's so far away from one another than compared to one that is just that you get to meet every day in school, isn't it? Right, speaking from personal experience. Okay, right. So no, I'm kidding. So, yeah. So this is basically what it means. But the one at the bottom is just a pictorial representation. But hopefully you are able to see how this format links together using the pictorial diagram. But the main thing I want to highlight to you that students tend to lose marks is these are the keywords. Okay. You need to mention that there's an attraction between the electrons and the positive nucleus. So if you're just saying that there's a weaker force of attraction from the electron without mentioning what the electrons are attracted to, you won't get marks. So you need to emphasize there's the attraction between the positive nucleus and the electrons. Okay, so this is all in all 11 marks. Have this been helpful? I do hope so, yeah, because this 11 marks technically is 10%. of paper 1, right? So it's an easy to score question. It's a very common question as well. So relook again in this question if you are not too sure. Alright, so far, if my summer revision package has been helpful for you, then show some bit of love for me, please. You can just like, subscribe, and then, yeah, comment if you have any question for me. Okay, cool. See you on the other side.